properties of alkanes, alkenes, alkynes. Remember, properties means like characteristics, like what are they like? So alkanes, by definition, are saturated because they're all single bonds, and saturated is all single bonds. So they always contain single bonds. They have this general molecular formula that we haven't talked about yet. So I'll talk about that later. An example of alkanes are like all oils and fats. Okay, they're all just these different length, long chains of just C, 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 H, 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 H. So because it's just like very even, just like C, 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 all single bonds, all like nice even H's around them, they're very non-polar. Because remember, polar means there's like a positive end and a negative end. It's very uneven. These are extremely even. So they are very non-polar. So there's no like positive end and negative end to like stick together. Oh my gosh, sorry. I'm just trying to make that message go away. So sorry, I got to pop up that my mother-in-law commented on my Facebook. Anyways, they're super nonpolar, so there's no positive and negative end to like stick together. So they have very weak intermolecular forces. They don't stick together well. So that means they have low boiling points. It's easy to get them to like separate into a gas form. So it's easy to get like a fat or an oil to boil, right? You put butter in a pan, it starts like sizzling pretty fast. Low boiling point. They're not very reactive because again, they're very even, they're very stable. So for a practice problem, you can't do this one yet, but it says, which compound is a saturated hydrocarbon? Alkanes, since they're by definition all single bonds, saturated single, saturated are all single, alkanes must be saturated. So that would be your answer. The one that ends in ane, so therefore is an alkane, so therefore is saturated. Alkenes, by definition, have at least one double bond in them, so they are automatically unsaturated. They have this formula, which we haven't learned about yet. They're going to be a little bit more reactive because at least now they're not like perfectly even. Somewhere in there they've got a double bond, which then, remember, it kind of puts that kink in it. So they're not so even now. So they're going to have like a little bit of polarity, a little bit of a positive and negative end. So a little bit of polarity. One example, so they will be a little bit more reactive. One example is ethene, and that is a chemical that makes fruit ripen. So we use it as humans, like when we want to ship some apples, but we don't want them ripe yet. Then when they get to the store, we can spray ethene on them and make them ripen. It's actually also a natural thing. So if you have one apple and it starts to ripen, it actually gives off ethene. And what happens is it then makes, let's just say that's an apple, I'm not going to draw it good, makes this apple ripen, and then that apple is going to give off some ethene, and it's going to make more apples ripen. So once one apple ripens, or even any fruit, if you have like a fruit bowl, it gives off this chemical ethene that makes the other fruit ripen too. So that's why they sometimes say like one bad apple can ruin the whole bushel, because if you have like one super ripe rotting apple, it's giving off tons of ethene that makes everybody else ripen, and then they give off more ethene, and then kind of everybody goes ripe and maybe too ripe and becomes rotten. And then alkynes, automatically, that means they have a triple bond. They have this formula we haven't learned about yet. So they're always automatically unsaturated, because saturated means single. So if you have any non-single bonds, you're automatically unsaturated. They're going to be even a little bit more reactive, because that triple bond is going to make them even more a little bit uneven. And a good example of a alkyne in real life is ethine. Ethine, when supplied with enough oxygen, burns extremely hot. So what would you need something to burn extremely hot for? Welding is something that we use for. We use ethine, and we burn it super hot, and we're hot enough actually to melt metals and melt them together. All right, and then lastly is just isomers. Isomers can have like the same formula, like this is C, 4 C's and 10 H's, and this is C4 and 10 H's. But you can see this one is butane, and this one is pentane with a methyl group. That's methyl or propane. So sometimes like just the formula can be deceiving, and it doesn't give enough information. And we call those isomers when something has the same exact like molecular formula, but its actual structure or structural formula is different. So that's an isomer. So a question they might ask is isomers, what's different about them? Not their molecular formula, that's what's the same. They both have the same number of C's and H's, which is the confusing part, but it's their structure that's actually different. That's what makes them isomers. Same formula, but different structure, and therefore different properties. They're going to act different. Okay, so here's a great question. Which of these two pairs, or which pair is isomers? So if you look at this one, this has 1C, this has 2C. Yeah, their structures are different, but their formulas are completely different, right? So those aren't isomers. Those are just two completely different molecules. The next one, C with H's and one OH over here, C with H's and one OH over here, those aren't isomers. That's just the same molecule flipped around. It's the same exact molecule. So these are just completely different molecules. These are just the exact same molecules, just flipped. So that's not an isomer. That's not what an isomer is. Let's take a look at this next one. This one's got 3 C's, 8 H's, and 1 O. This one's got 3 C's, 8 H's, and 1 O. Okay, those are the same formula. Do they have different structures? Yeah, this one's got an OH stuck on the end. This one's got an O stuck in the middle. So this right here, this is an isomer. Same formula, different structure. D is not an isomer because it doesn't even have the same number of C's. That's just a straight up, just totally different formula. So to be an isomer, you have to have the same formula but different structure. And that's where the confusion is, and that's why they have this special name called isomer.